for today for August 25th in Blackboard. You have several options for submitting it. I'm going to close this here quick. You can either, as I said, you can print, complete, and then scan it and back into me if you have that ability. If you can print but don't have a scanner, you can, as long as you can get it large enough that I can see it, you can take a picture with your cell phone or whatever and send me that picture in an email. Or if you don't have the ability to scan or take a picture or print even, you can just download it, complete it, and submit it electronically. So just submit it as an attachment, as a Word document, electronically. And all of these, remember, in your email, in your subject line, make sure you say residential construction or woods is kind of our nickname for you, and quiz in that subject line. So I know that it's a quiz from you guys. I can get it, I can handle it accordingly on my end. Because if it doesn't say quiz, if it says question, then I'm going to get to it a little quicker, make sure I get back to you as fast as I can. The quizzes I'll set aside till I got all of them and then grade them at once. Is there anybody that's unsure or has questions about how to go about accessing that quiz and completing it? You're good? Okay.
Mm-hmm.
Okay, so we'll move on to our next step then. Normally it would take a few minutes here in class to do the quiz, but I think we chewed up most of that time getting everything logged in here today anyway. So let's go ahead and start our next topic. We've talked about the different operations of numbers, the basic operations of numbers. Today I want to look at what happens when we run into something like this. Where we have multiple numbers and multiple operations going on. Now, most of you have seen this and know what to do with it, but for somebody who hasn't, there are a lot of different ways that you could interpret this. One way that you might interpret it, we read left to right, you might complete it left to right. Don't write this down because it's going to be incorrect. But you could do the 17 minus 3 is 14. 14 times 5 is 70. And 70 plus 8 is 78. That makes perfect sense, but it is incorrect. There are several other ways that you could interpret that problem, and all of them would give you potentially different answers. Well, in math, we like to have two people do the same problem and get the same answer. To guarantee that, we have defined something called the order of operations. Now, the order of operations has been misinterpreted in most cases as being a set of steps. It's not really a set of steps to complete a problem. What it really is it is a set of levels of priority. When there's more than one thing that can happen, the highest priority, wow, I butchered that spelling. There we go. The highest priority happens first. And most of you are fairly familiar with the steps. These might look slightly different than what you've seen. But the first step is something called enclosing symbols. Now, many of you have heard this said as just parentheses. And parentheses are the main type of enclosing symbol we see. But there are several other types of enclosing symbols that we will encounter as we do sample problems. The second is something we haven't discussed at all, called exponents. Exponents are another set of operations like the addition and subtraction pair and the multiplication and division pair. Exponents includes a pair of operations called powers and roots. Third level of priority, that would happen if after exponents would be the multiplication and division. And then the lowest level of priority, things that only get done if there's nothing else to do, is addition and subtraction. So you only do addition and subtraction if there's nothing else that can be done at that point. Those are our lowest of priority. So let's go back to this original problem here. 17 minus 3 times 5 plus 8. Well, there are no enclosing symbols. There are no exponents, so we don't have to worry about those. But there is multiplication or division. We have 3 times 5 here. So that's the part that has to happen first. So what we do is we combine those two numbers with the operation indicated, and we replace the two numbers with the new one. 3 times 5 is 15, so replace it with 15. The rest of the problem gets rewritten exactly as it was. Nothing else changes. Now there is no more multiplication and division. We can check that off. There's addition and subtraction. Now there's more than one. There's both addition and subtraction here. So what we do when that happens, if there's more than one item on the same level of priority, then we do work left to right, just like reading the book. So here, addition and subtraction have the same priority, so we're going to do left to right. So the 17 minus 15 is first. That's a 2. And then finally, we have 2 plus 8 gives us 10. So that problem reduces to a 10. Now, if you're working on the scientific calculator, the scientific calculator does do the order of operations perfectly. You can see mine, and when I punch it in, spits out a 10. Couple of issues there. So as we get into more complex problems, some of them can be kind of difficult to enter correctly in the calculator. Some of them can be nearly impossible, as we'll see in some of our examples coming up. But let's take a look at something just a little bit more complex. Eight plus 7, parentheses, 16 minus 3 times 4, close parentheses, minus 5 times 2. So a little bit more complex, has a few more things in it. Well, again, our order of operations. First level of priority, highest priority is enclosing symbols. We have that here with the parentheses. So what that means is we have to look inside those parentheses first and do what's in there first. So we're basically narrowing our focus. That's the new problem we're looking at, is only what's inside the parentheses. Well, inside the parentheses, the order of operations still applies. There are no other enclosing symbols. There are no exponents. There is multiplication, 3 times 4. So 3 times 4 is 12, so replace it with 12. Everything else in this problem gets rewritten exactly as it was. I've actually found through the years that more mistakes are made in rewriting the problem than they are in trying to do the calculation. So be very careful with that. Now we're still dealing inside the parentheses, inside this blue box. The last thing that needs to be done there is the subtraction. 16 minus 12, which is 4. So replace the 16 minus 12 with 4. Once again, everything else in the problem stays exactly as it was. Now at this point, we've reduced what's in this set of parentheses to a single number. What that means is we no longer need that enclosing symbol. We can get rid of it. When we do that, we have to check for a couple of things. One is there anything that we have to do to get rid of the symbol? Well, this is just a parenthesis, so there's nothing we have to do. There are other symbols like roots and things like that we have to do something when we get rid of it. This one, there's nothing to do. The second thing we have to check for is if there are any implied operations that symbol was signifying that we have to make sure are marked if it's gone. And in this case, there is. That 7 is in front of the parentheses with no operation there. It is implied that is multiplication. It's been multiplication all along, it just isn't written because a number outside of a parentheses is implied to be multiplying what's in that parentheses. When we take out that parentheses, we have to make sure that multiplication symbol is there so we know that it is 7 times 4. Now we can continue. We've finished that enclosing symbol. So now we're going to go back up our levels of priority. There are no more enclosing symbols. There are no exponents. Multiplication and division, we're going to go left to right. So going left to right, we have the 7 times 4, which is 28. So replace 7 times 4 with 28. And the rest of the problem gets rewritten. We have the only multiplication or division left is 5 times 2. 5 times 2 is 10. We replace that with 10. Everything else gets rewritten. Now, one little trick that I do is, you see, I put a box around the numbers I'm combining. Everything that's not inside that box then has to be written in the next line. Now down here, there's no more multiplication or division, so all that's left is addition or subtraction. I'm going to go left to right. So 8 plus 28 is 36. Rewrite this the problem. 36 minus 10 is 26. Anybody beat me to that? Had that answer before I got to it? Few of you? Good. Well, let's step it up a little bit to something a little bit more difficult. You're going to learn rather quickly in this class. I always make it worse. That's kind of my job. I do kind of enjoy it too, I will admit to that. Just a little bit more complicated. This one's not as terrible as it looks. We just have to make sure we go step by step. It's going to be a lot of writing. I'll admit to that. So we go through our levels of priority, our order of operations here. First level is enclosing symbols. Well, we have several parentheses here, so we go left to right. Going left to right, this is our first parenthesis. So we have to find its other end, its mate, if you will. So we keep going. Well, this one's facing the wrong way. That's not its other end. This one here goes with that one, so that's not its other end. Here is the other end of that original parentheses. So that is our first enclosing symbol. We're focusing our attention inside the blue box. Inside there, however, order of operations still applies. And there's another enclosing symbol. We have another parentheses here. So now we focus our attention inside that enclosing symbol, inside the green box. Well, in there, there's only one thing that needs to be done. 7 minus 3 is 4. So the rest of that problem gets rewritten exactly the way it was. Now, this parentheses here that we had, is down to just being a single number, so we don't need that parentheses anymore. But when we take it out, we see there's a 4 in front of it. That's got to be multiplication put in there. Now that's one of the things, normally if I were doing this on my own, I wouldn't have rewritten the whole problem with the parentheses in there. I would have just seen it was a single number, and I would have written it as I'm doing here in brown right away. Without the parentheses in at this step, I'd have just put the multiplication in there and saved myself a line worth of writing. So there we are, we've dropped that parentheses. Well, we are still working inside this set of parentheses. In there are no other enclosing symbols at this point. So we go to our next level of priority, which is exponents. And we do have both a root and a power, but going left to right, the first one is the square root of 16. What's the square root of 16? 4, good. So replace that with a 4, and we rewrite the rest of that problem. So now, again, we're still working inside that parentheses. There is another exponent yet. That is the 3 to the power of 2, the power. What's 3 squared?
9.
9. Good. 3 times 3 is 9. So replace the 3 squared with 9, and we rewrite the rest of that problem. So again, still working inside that parentheses, we are down to multiplication and division. Going left to right, we first run into 6 times 8, which is 48. Now, I get asked all the time, well, can't we do multiple multiplications and stuff at the same time? In some cases, we can get away with that, but we have to be very careful because there are times where that can screw us up. This would be one where there's a good potential for that, because the next thing we really should do here is the division, because we're multiplication and division going left to right. That would be the next one completed. 48 divided by 4 would be 12. And we rewrite the problem. Now, when you're first starting out, first of all, you won't have many that are this long, so you won't have this quite this much writing to do on many problems. But I do highly recommend that you do rewrite the whole problem at every step when you're starting out, just because it does avoid a lot of mistakes. It's when you start trying to skip parts of it, skip steps, or do 2 steps at once, that I see most of the mistakes made. Now we're multiplying and dividing left to right inside the parentheses. Next is the 5 times 9. That is 45. I will show you a shortcut that I use in the next problem here. And then next, we've still got multiplication and division inside that parentheses. 4 times 4 is 16. So we are done with all the multiplication and division inside that parentheses. So we're going to move down to the next level, the final level, which is addition and subtraction. So left to right, still inside the parentheses, remember. We have the 23 minus 12, which is 11. Still inside that parentheses. Next we have 45. Oops, get back here. 11 plus 45 is 56. Still inside that parentheses, we have 56 minus 16, which is 40. Now we see that we have the 40 plus 1 as our last thing. We're going to be down to a single number in that parentheses. I'm going to take out the parentheses as well, rather than do it as a second step. Remembering to put in the multiplication for that 2. So this is 27 plus 2 times 41 there. Next, we have other enclosing symbols to move on to. So we've got this one here, and there's its other end. Well, inside there, we once again have another enclosing symbol, this parentheses, the 8 plus 3, which is 11. That reduces that to a single number, so I can take out that parenthesis. So I have 16 minus 11. I don't need to put an operation in front of this parenthesis because there was already the subtraction there. I only have to worry about putting in multiplication if there's a number there without an operation. So then my final enclosing symbol will be this 16 minus 11, which is 5. Again, I can take out that parentheses. And again, there's already an operation here, so I don't have to put in multiplication. Enclosing symbols are done. No other exponents. We got somebody has a lot of background noise. Do we know where that's coming from? If you do, if you could mute your microphone for me, I'd appreciate it. Got the dog. Okay, so next we have multiplication and division. We just have the 2 times 41, which is 82. Then we have all that's left is addition and subtraction. 27 plus 82, 109. And then the 109 minus 5 is 104. There's our answer, 104. Now that was, to say the least, pretty ugly. Not going to deny that. That was an ugly problem to do. I'm going to show you a little bit of a shortcut on one that's not quite as long. So something like this. What I normally do on a problem like this, because I have the ability to erase easily, is I will rewrite the problem once. And this is where if you're doing homework or whatever and you want to use any of the whiteboards in the room, I don't know if they took all the markers out or not. Hopefully they left them there. If you use a marker, they just want you to make sure you wipe it down when you're doing your cleanup at the end of class. Anyway, I rewrite the problem once, and now as I go through, I'm just going to erase and replace. So my closing symbols have to work inside that set of parentheses there. Inside there, I have exponents, the 2 squared. Well, 2 to the power of 2 is 4. So I'm going to erase the 2 squared and replace it with 4. Notice I was careful to erase it, so I didn't erase the multiplication in front of it. The next piece that would have to be done there is multiplication and division left to right. So I've got 5 times 3 is 15. So I'm going to erase the 5 times 3 and replace it with 15. I have the 3 times 4, which is 12. So I'll erase the 3 times 4 and replace it with 12. Inside the parentheses, the last thing I have is 15 minus 12, which is 3. So I replace that with 3, and the parentheses is down to a single number, so I can take out the parentheses. I do have to put multiplication in there because it was 2 outside the parentheses with no operation. And now I'm going to rewrite this just because it's getting a little spread out. Next, there's no more enclosing symbols, no more exponents. So I have multiplication. 2 times 3 is 6. 18 minus 6 is 12. Excuse me, and 12 plus 1 is 13. Not so bad?
Mm-hmm.
I'm going to have you we're going to look at a different type of order of operations problem here, one that looks like this. (14 times 2 plus 5 times 4 over 5 squared minus 27 divided by 3. Now, in order to work with this problem, we have to figure out what this line here means. Now, most people would say division, and it does mean division, but it's called a fraction bar. And it's also an enclosing symbol. It separates part of the problem from the rest. It separates the top of the problem from the bottom of the problem. So what it's telling us we have to do is we have to do each of those parts first, then we have to divide. Doesn't matter, it doesn't matter if we do top or bottom first, as long as we do each of them separately. So I'm going to rewrite the top over here so I can do that first. So no more enclosing symbols, no more exponents. So I'm going to do multiplication and division left to right. 14 times 2 is 28. Then I have the 5 times 4, which is 20. 28 plus 20 is all that's left. That is 48. So the top of that reduces to 48. On bottom, are no more enclosing symbols, but there is an exponent, a power. 5 squared is 25. Then we have to do the 27 divided by 3, which is 9. And last is 25 minus 9, which is 16. So the bottom of that reduces to 16. And now we do our division. 48 divided by 16 is 3. Now, this problem is very important because all of these previous problems that we've done could be entered in the calculator exactly as they appear here. Even this ugly beast that we did, I can do 27 plus 2 parentheses 23 minus 6 times 8 divided by the square root of 16 plus 5 times 3 squared minus 4 parentheses 7 minus 3 parentheses plus 1 parentheses minus parentheses 16 minus parentheses. It's a mouthful just to punch it in the calculator. But notice, it gives us the same answer that we got when we did it out by hand. So the calculator handles these order of operations, and those problems like this are relatively easy to enter into it. This problem, however, that we just did is not so easy to enter into the calculator. what I would suggest, if you're going to use the calculator for it, treat it almost like it's 3 separate problems. Punch the top part into your calculator and get the top number. Punch the bottom part in your calculator, get the bottom number, then go back and divide them. If you try to enter that all at once, 9 times out of 10, you'll enter it incorrectly. There are a few calculators out there that actually have that fraction bar where you can enter the top and bottom, but not many of them. So just a word of warning, this is one where entering it in the calculator can be tricky. Next example. Looks like this. Now, as we go through our order of operations here, we see right away that there is an exponent. There is a root here. But that square root symbol is also acting as an enclosing symbol in this case. It is separating this part of the problem. So that part of the problem there has to be done first. The 79, or 7 times 9 plus 1. So inside there, the first thing that has to be done is the multiplication, the 7 times 9, which is 53. Then we have the 63 plus 1, which is 64. Now we have reduced that what's inside the enclosing symbol to a single number. So just like the parentheses, we can take out that root symbol. Unlike the parentheses, however, we actually have to do something when we take it out. When we take out that square root symbol, we actually have to do the square root. What's the square root of 64?
8.
8, perfect. Also, just like the parentheses, we have that 2 in front. We have to put multiplication in there. Now we have the 2 times 8, which is 16. And 33 plus 16 is 49. Now, these are definitely a lot of work. I'm not going to argue that. I am going to give you a few minutes here to get started on the homework and the big book. It's page 26, labeled exercise 1-11. I want you to do problems 7 through 39. Again, just the odd numbered problems. Just like the other book, the odd numbered problems in the big book are in the back, so you can check the answers yourself. So please do that so that when you come into class, you can, if you have anything you couldn't figure out, you can ask questions on them. And in the little book, it is Unit 5. And again, just the odd numbered problems in Unit 5. If you don't have the little book yet, I know a couple of you are waiting for that. I believe in the big book it is 1-12. Let me double check here. So it is section 1-12, page 27, 28. If you're doing it, if you don't have your little book yet, you can do that in place of it. So that's if you don't have your little book yet, you can do that. Okay, so I'm gonna give you the last 5 minutes here to get started on your homework. Remember, at some point you got to get that quiz offline and work on that as well, and get that submitted before class tomorrow.
Yeah, the little book. 5.
Oh, okay. Do you guys already see the questions 7 through 39? I know it's odd, but do we have to do every single?
Yeah.
Remember, just like last time, just like yesterday, if you do a couple of the easier ones and they seem real easy, please feel free to skip ahead to the more difficult ones towards the end of the page. Um, just make sure you do 2 or 3 at least of the more difficult ones so you know that you're ready for a quiz.